Welcome back. We've got a blade completed, and so next up is the grip. The quillins and the pommel are pretty typical on this dagger, but the grip itself is going to be alternating layers of wood and bronze, so it's going to be a little bit of a challenge. The first step in that process is to prepare the tang, so we'll get started with that. Getting the grip to socket onto the tang is one of the more challenging aspects of making a dagger, which is made easier by having very consistent profile to the tang and the shoulders. Here we're somewhat destructively using the face of the vise as a filing guide to make sure the two sides of the tang are parallel. Some designs call for a tapered tang to keep everything tight, but we're going to accomplish that with a pommel nut. You can see I've already rough cut the major components, and the next step is to clean them up. I'm going to be using the mill to do that. So here I'm loading up a carbide end mill, and we're going to face off all these parts. All the components are very rough. They were cut from a box of scraps. The first thing we need to do is set it in the vise and run the end mill across one surface so we can establish at least one flat plane. My daughter's taking over on the milling now. She's running the table side to side, slowly stepping the Z-axis down into the part, and she'll continue to do that until the cut takes off the entire surface. You can see this pass only cut off the back corner, and that means that it is not flat yet. You can see with this pass we've actually cut the entire surface. That means this side is flat now. So we will remove the part, flip it over, and repeat this process, and we'll end up with parallel sides. Once we repeat this process with all of the parts, all of the components can be stacked up without any gaps in between them. Next up, we're going to socket most of the main components. The perimeter of this really isn't square, but I'm going ahead and marking center anyways, just because I want to maintain as much of this material as I can. Our components are fairly short. So here I'm loading up a 3/16 end mill, which is just slightly narrower than the thickness of the tang. The first step when milling something like this is to zero out your digital readout, which in this case is centering the mill directly over that center punch that we made. And right now I'm just going to be eyeballing it. This is not a super important operation to have this perfectly centered, and just eyeballing it is good enough. The width of the hole, however, is very important because that needs to fit snugly onto the tang of the dagger. Here you can see the other benefit of using a mill to do this operation. If we were to use a drill press, you'd have to drill multiple holes to accommodate the wider dimension of the Tang. But here we can just feed the table front to back to widen the socket out. The mill left a pretty good sized burr on our piece, so we're going to smooth that off with a file real quick, and then we'll move on to the next part. All the other layers of the handle are done in exactly the same way. Here we're doing one of the wooden segments. There is one additional complication with the wood. It's too tall, so we have to flip it over and drill in from both ends. After that, we swap to a larger end mill, and we move back to the crossguard, which is going to be shaped like a paper scroll, where the ends are a little thicker. So we're going to use this larger end mill to hog out about half of the thickness of the center of the crossguard. Here, a child who's not yet realized that he's left-handed has sketched out what that paper scroll will look like. The grip of the dagger is going to be round, and we're going to accomplish that by fully gluing the handle up and then rounding all the pieces at once at the belt sander. However, that will not work for the piece of bronze that's directly behind the crossguard, and that's because the crossguard will be in the way. So we're going to individually round this piece off at the lathe. Now, unfortunately, we do need the full thickness of this piece rounded, so that doesn't leave us anything to clamp into the jaws of the lathe. The bad solution I came up with was to drill and tap a hole through the piece and then mount it on a nut and bolt. Then I could clamp the lathe chuck down onto that instead of onto the piece directly. I was able to finish the piece doing it that way, but it was terrible. It was really flexible and it left a really bad surface finish, but I was able to complete the part. Now, once the part is fully spun up, we will use these two feed dials to slowly walk the tool back and forth across the surface of the part, removing layer after layer until we get a perfectly round part. And now that we've got the part perfectly round, I'm going to use hand files to file in the decorative profile. We're going to try to finish this part as much as we can. And you can see I'm using the lathe to make sure that I keep the part round and don't overfile one side or another. And there you have it. This should be really similar to the design we cut into the blade last week. Now we just need to socket this piece, and unlike earlier, it's very important that we get this socket cut centered because the piece is already shaped. To do that, we're going to use a coaxial dial indicator. This is one of my favorite tools. It's a measurement device that mounts in the tool holder of your mill. And out of the bottom of this is a little arm. You rest that arm against a part that's mounted in your mill, and the dial will indicate how far that arm is being deflected from center. Now I can hear you asking, hey, how do you center something when you can only measure in one direction? And this is the part that's so cool about it. You use it with the mill running. This leads to a lot of really chaotic movement in that dial, but since that dial is indicating how far the arm is deflected from center, once you find the center, the dial will stop moving. And here you can see the dial is only bouncing around about 3/1000ths of an inch, so that's pretty darn close to the center. So we're going to stop and zero out the DRO, and we'll mill the socket now. And now we just clean it up, deburr it. And beautiful. We have got a lot more to do on this grip, but I don't want this to be a 30-minute video. So if you tune in next week, you will see the next part in that process. If you're interested in that, hit the subscription button, the notification bell, and I'll see you then.